Yes, it was. So if I want to factor 4f squared minus 64, the one thing you guys can look at this when you see two terms is to look at the possibility of factoring by using the difference of two squares. So the difference of two squares means when you have a squared number subtracted by another squared number, you can write that as a factored form of a plus b times a minus b. So to see if we can solve this problem as a difference of two squares, we want to see, can we rewrite this as a squared term minus another squared term? Well, 64 is pretty easy to say that, yeah, we know that's a squared term. That's 8 squared, right? So we could say that's 8 squared minus 64. But can we write 4f squared? Well, we know that 4 is a squared number, that we can write that as 2 times 2. And f, that's a squared number too, is f times f. So we could write this as 2 squared f squared. But that doesn't really look kind of the same, does it, right? However, remember the power of product rule says that if I'm taking a power to both of them, I can just rewrite that as 2f squared minus 8 squared. So now, in this example, you guys can say that a equals 2f and b equals 8. So now I have one term squared, my a squared minus b squared. So when writing this in the factored form, I can now say I get 2f plus 8 times 2f minus 8. Cool? Yes?
Why do you have to put it like 2f squared minus 8 squared?
I didn't. I just saw that 4 is 2 squared, and f is f squared. So or f times f. So I was just rewriting it, yeah, so you can just take a look at it. You don't have to do it like that. Make sense, kind of?